Hello, this is Captain Chaudhari. In my today's lecture, I'm going to talk about a special situation of dry docking. Sometimes the companies might have instructions to their officers that GM at critical moment should not be less than say 30 centimeter or 40 centimeter or 50 centimeter. So what is the maximum trim at which you can arrive the dry dock? I told you before also, the minimum trim is decided by the declivity of the blocks or the dock master, and the maximum trim will be decided by the stability requirement of your company or stability requirement of the ship. Now the stability requirement here is at critical moment, at critical moment, which is kind of worst moment, in the critical period, the GM should be still 40 centimeters. So the condition that is given in this question is GM at critical moment, GM virtual at critical moment, which probably is the least GM in the critical period, the most dangerous moment of the critical period. The GM should not be less than 40 centimeters. Now applying the condition that is given in the question, right? We can make an equation, and that equation would be Km minus Kg minus the sum of free surface correction and the virtual loss due to dry docking, that is FSM upon delta minus P plus PKG divided by delta minus P. This should be equal to 0.40, or it should be more than or equal to 0.40, but we are trying to find out the limiting condition for 0.40. Now we will take the Km for the free floating condition because we don't know any other water level that is going to arrive during the dry docking as yet, because we don't know the trim. So we'll take 9.6 minus 7.6, that is a kg, minus free surface moment is 600 tons meter, divided by delta minus P plus 7.6 into P divided by delta minus P equal to 0.40. So this is 2.0 minus 600 plus 7.6 P divided by delta minus P equal to 0.40. This means 2 minus 0.40, that is 1.6, equal to 600 plus 7.6 P divided by delta minus P, which means that therefore delta minus P into 1.6 equal to 600 plus 7.6 P. Delta is 5200, so 5200 into 1.6 is 8320 minus 1.6 P equal to 600 plus 7.6 P. This minus 1.6 P goes on the other side. It becomes 9.2 P, and 600 comes on this side, so it becomes 7720. 7720 divided by 9.2 gives me 839.1. P is equal to 839.1. Now this upthrust 839.1 ton, which I have found out, I would call it P approximate. Why I will call this as P approximate? Because Km that was used in my equation was a Km for free floating draft. Now we must actually, in any calculation, we must actually apply the Km at the current moment. That means km for the present virtual displacement. Now in the question it is given that km at the approximate final draft is 9.7. So we will redo the calculation using the km as 9.7, and in the same equation km minus kg minus FSM plus pkg divided by delta minus p equal to 0.40. In the same equation I will write now km equal to 9.70, kg is 7.60 minus FSM 600 plus pkg will be 7.6p divided by 5200 minus p equal to 0.40. Now this one is 9.7 minus 7.6, that is 2.1. This 2.1 will go now this 2.1 and 0.40 comes on this side, will make it 2.1 minus 0.40, that is 1.70, and this will be equal to 600 plus 7.6p upon 5200 minus p. Cross multiplying, we'll get 5200 into 1.7 gives me 8840 minus 1.7p equal to 600 plus 7.6p. This 1.7 goes on the other side, makes it 9.3p, and on this side we have 8240. So 8240 divided by 9.3 gives me P accurate as 886 tons. So P accurate is equal to 886 tons. So this is the unique dry docking question where we do not know the initial trim. In fact, we have to find out what is the trim with which the vessel must arrive the dry dock. We are missing that formula. We are missing that equation. And what is that equation? That equation is P into LCF is equal to trim change into 100 MCTC. Now this is one of the rare questions where in dry docking we don't know the initial trim. In fact, the ship's officer wants to find out what is the maximum trim with which the ship must arrive the dry dock. In other words, we so far do not know what is the trim, but we know the maximum upthrust that can be generated, that is 886 tons. We'll use the same equation which we have been missing, P into LCF is equal to trim change into 100 MCTC, and therefore trim change is equal to 886, that is P multiplied by LCF 76 divided by 100 into MCTC. Therefore trim change equal to 2.405. Now we are assuming that the dry dock does not have any declivity. Because the dry dock does not have any declivity, trim change will be equal to the initial trim. So we assume that the initial trim therefore is 2.405 meters. We know the hydrostatic draft, we know the initial trim, so we should be able to find out the fore and aft draft. So in this trim that is 2.405, what is the aft component? TA. Aft component TA will be 2.405 into LCF 76 divided by LBP 160. 2.405 into 76 equals divided by 160 gives me 1.142, and TF should be equal to total trim minus TA. So I subtract this from the total trim, 2.405 gives me 1.263. 1.263. So now the initial forward draft will be hydrostatic draft minus TF, and aft draft will be hydrostatic draft plus TF. So hydrostatic draft, that is 4.54 minus 1.263 gives me 3.277, and the aft draft will be hydrostatic draft, that is 4.54 plus TA, that is 1.142, gives me 5.682. Now this is the free floating condition, finding out the fore and aft draft using the trim and the hydrostatic draft using LCF. So LCF which is used should be the LCF for the free floating condition, right? Not for the final condition, because we are talking about the free floating situation. So this is how we find out the maximum trim or the draft with which to arrive the Drydock, so that the GM at critical moment, the virtual GM at critical moment, is not less than 40 centimeter.